Hello, and welcome to the next lesson of Big Data and Hadoop Administrator course. That is Hadoop Cluster Planning. After completing this lesson, you will be able to planning a Hadoop cluster, general planning considerations, workload and cluster sizing, Hadoop cluster setup options, physical, virtualization, cloud, or hybrid, making choices, hardware, software, and network, making choices, master-slave considerations, news from the world, existing setups. In previous lessons, we learned about cluster setup and deployment, and managing a cluster with its services and components. Now let's learn cluster planning, an aspect which starts way before the bricks of a cluster are laid down. To plan your Hadoop cluster, you have to know the requirements of business, know the eventual profile of workload, estimating and cluster sizing based on estimations. You also have to choose the right setup options, which may consist of physical machines or cloud platform, or virtualization options, or a hybrid kind of setup. Hadoop cluster planning also involves understanding the variables, such as hardware, software and network, understanding the deployment types, and many times, learning from other setups. You have to know and understand the requirements to plan a Hadoop cluster. The requirements may be, but are not limited to, need. What is the need of a Hadoop cluster? Data type. What kind of data will it handle? Volume. What is the volume of data under consideration? Speed. How quickly will data grow? Processing. How frequently do we need to process it? Cost. Are there any budget constraints? Workload. What will be the eventual workload pattern? Time. How much time do we have to set up and bring the cluster to a ready status? Resource consumers, applications. How many applications would be supported by the cluster? Cluster sizing tool, manual. Will we use cluster sizing tool, calculator, or rely on experience and expertise for planning and estimation? Size. What would be the appropriate size of the cluster? The responses to the requirement gathering queries, as seen on the previous screen, may highlight a few questions which organizations have to ask themselves and take an appropriate decision towards cluster planning. Need. Is it for delivering new business value? Or is it for delivering data center efficiency? Requirement of Hadoop cluster may be for a new business or when Hadoop has to be integrated to existing infrastructure to make it more efficient. Data type. The cluster might be used to handle a variety of data, which may be generated from various sources. Volume. The data volume can be graded in magnitude of terabytes, petabytes, and exabytes, and understand its retention requirement. Speed. The data growth can be categorized as expected or unexpected. Processing. The frequency of processing of data would be directly proportional to the choice of resources in cluster. Cost. The cluster might be bound by budget constraints, or it might be free from any financial limitations. Workload. The workload pattern may be network intensive, I/O intensive, CPU intensive, balanced workload, or evolving workload. Time. If time is a constraint, the usage of cluster management solutions will be preferred, and if not, open source Core Edition should be used. Resource consumers, applications. The count of applications supported by the cluster affects the cluster size and count. Cluster sizing tool or experience. While cluster planning, the question is whether cluster sizing tool or calculator should be used, or whether the plan and estimate should be based on experience and expertise. Size. The size of the cluster could be decided based on the above requirements. On the next screen, we will look at a sample tool delivered by one of the vendors, which helps estimate the hardware, infrastructure, and provides a few recommendations. This cluster sizing tool gathers the requirements, through some questions which intend to evaluate the requirements and suggest recommendations for an efficient cluster planning. The following questions are asked. How are you planning on using Hadoop? The options available in the tool are Deliver new business value and Deliver data center efficiency. What type of data are you handling? The type of data handled by the cluster may include clickstream data, data for sentiment analysis, data from sensors, machines, data from geo-tracking devices, server logs, text data, etc. How often do you intend to process your data? The cluster utilization for processing of data could be continuous or frequent, historical or regulatory. How quickly is your data growing? The growth of data on your cluster could be regular or exponential. This is a sample output from the tool, based on the options selected on the previous screen. The tool shows the hardware, infrastructure estimates, and provides recommendations such as physical or network isolation that may benefit the cluster. Actual cluster sizing and configuration is a much more complex process than represented in the tool. However, this gives an idea of the factors that may affect the estimates in cluster sizing. In the next topic of this lesson, you will learn about workload patterns and their impact on choosing the right hardware, software, and network for a cluster. We know that Hadoop clusters are used for massive data storage and processing. We now need to understand the workload patterns and its impact on the choice of hardware, software, and network for our cluster. A few important parameters affected by workload patterns and which contribute to the decision of accurate hardware sizing are disk space consumed and choice of storage devices, I/O bandwidth required and network settings, and computation power required for processing. One of the initial tasks when planning a Hadoop cluster is to understand workload patterns. This directly impacts the choice of the right Hadoop distributions with the required features, appropriate versions, and services, and underlying OS with the appropriate system services. Hadoop architects usually ask a few questions when they try to understand the workload patterns. Are the data access patterns uniform or skewed data access? Data access patterns say a lot about your workload. Over the lifetime of data, some data sets are more valuable than the rest and are also accessed more. The nature and cause of such skew offers insights into the cluster's performance, and it helps us determine the workload pattern. Moreover, comparing workload patterns across industries helps us identify similarities and choose the best strategy for planning our cluster. We may want to determine or estimate average data set sizes in our cluster so as to be proactive in deciding the storage and cluster size. The following may be additional questions that architects ask. What is the frequency of accessing and reaccessing data? How does load vary over time? Regular cycles or predictable? What is the frequency and size of load bursts? What are the compute patterns? What is the ratio between compute and movement of data? What are the common processing types? What is the usage of high-level query language or Java? Let's understand the typical workload patterns which drive the decision of selecting an appropriate hardware for your Hadoop cluster. The selection of right hardware provides the best balance of performance and economy for a workload pattern. Hadoop is not unlike traditional databases or processing systems, where the ratio of CPU to memory to disk is influenced by the workload. Some knowledge of intended workload will increase the chances of optimum utilization of hardware. The typical workload pattern types include compute-intensive workload. Compute or CPU-intensive workloads are characterized by the need for a large number of CPUs and a large amount of memory to store large in-process data. Some examples include processing that involves classification, complex text mining, natural language processing, feature extraction, and so on. I/O-intensive workload. MapReduce processing that involves sorting requires less compute power and relies more on I/O operations. This may require more reading and writing to disks, thus emphasizing on investment in disks. Other examples include indexing, grouping, data importing and exporting, data movement and transformation. Network-intensive workload. Various running jobs may involve a lot of data transfer across nodes, thus necessitating a high bandwidth, bonded network interface cards, NICs, for higher throughput and racks to accommodate nodes. Balanced workload. Here, workload is distributed across the cluster evenly across various job types, and the workload doesn't belong to one specific type of workload pattern. Unknown or evolving workloads. An environment where estimating the eventual workload may be difficult due to varied ongoing processing and dynamism of the business. Examples may include research and development. Here is a picture that demonstrates configuration of machines according to the workload. In the last topic, you will learn about cluster setup options and the considerations that should be made in terms of hardware, software, and network while setting up a cluster. Now let's learn about the different cluster setup options available. The choices of infrastructure to deploy a Hadoop cluster include physical machines, on-premise, cloud like Azure, AWS, and so on, virtualization software, and hybrid environment. Hybrid deployment offers the best of both worlds, on-premise and cloud. The main benefits of hybrid deployment are cluster backup options. Architects prefer to have high business continuity through replication of data on-premise and use of cloud-based storage. Development. Organizations prefer to keep production environments separate from development and prefer to use cloud for their development work while persisting data on clusters in-premise or on cloud. Data exploration. Organizations prefer a cloud platform for the computation and storage capabilities that it offers. Example: Microsoft and Hortonworks have joined hands to offer a hybrid deployment model that provides companies with the benefit of control, flexibility, elasticity, and redundancy. It provides access to the breadth of analytic cloud services. You will learn about the different hardware and software considerations while setting up a cluster on the upcoming screens. Hardware considerations involve selecting the appropriate hardware and considering other factors like NICs, power supply, cooling, RAID, or JBOD disks configurations, and considering RAM and rack for both master and slave nodes. These selections also depend on cluster size, business requirement, and criticality of the process running on the nodes. Hadoop hardware comes in two different classes, master nodes and slave nodes. To avoid heterogeneous platform and reduce proliferation of hardware profile, architects select a single profile for master nodes and slave nodes. Master nodes. Master nodes serve critical functions that the cluster can't live without. These require a higher cost for machines with high-end features. Here is a sample hardware baseline profile based on the size of the cluster. Small clusters of up to 20 nodes have dual quad-core 2.6 GHz CPU, 24 GB of DDR3 RAM, and dual 1 GB Ethernet NICs, a SAS drive controller, and at least two SATA 2 drives in a JBOD configuration, in addition to the host OS device. Mid-size clusters up to 300 nodes usually benefit from an additional 24 GB of RAM for a total of 48 GB. Master nodes in large clusters should have a total of 96 GB of RAM. Name node stores metadata in RAM and consumes approximately 1 GB RAM for 1 million blocks. Following are the points to be considered while setting up a cluster. Do not use commodity machines. Use dual power supplies, dedicated cooling, bonded network interface cards, NICs, and rated disks. Use machines with good RAM and nominal or moderate disk capacity. The OS for master machines should be highly available, thus RAID hard drives. Add good amount of RAM to store metadata. It should have access to NFS to have a copy of metadata disk. Another variable of cluster planning is choosing software to be installed and run on the cluster nodes. These may be Hadoop or non-Hadoop related. Software considerations involve selecting the following: the right Hadoop distribution, free or licensed distribution, the right version of Hadoop according to the desired features and stability, the appropriate OS, Linux distribution or Windows version. The choice also depends on the desired features, capability, and stability required on your OS hosting Hadoop cluster. Network considerations is the most challenging parameter to estimate due to varying workloads. The following needs need to be given thought. The Hadoop network should have intensive bandwidth. It should have dedicated and preferably top-of-rack switches. The nodes should be connected with a minimum speed of 1 GB a second. The nodes should have more speed for large amounts of intermediate data, such as 10 GB a second. Large clusters typically use 1 GB links for all nodes in a 20-node rack, and 2 into 10 GB interconnect links per rack going to a pair of central switches. 1 GE oversubscription between racks. Consider a cluster with 10 data nodes and each data node with a storage capacity of 20 TB. Default replication is enabled and data grows by 5 TB a week. This would need approximately 15 TB of storage space every week. Assume overheads to be 30%. This includes storage space required for the OS file system, logs, and any other data residing on disks and so on. When do you think storage would get exhausted and you would need to add more data nodes to the cluster? Answer: you will have to add more data nodes approximately in or before the 9th week. By then, the storage space in the data nodes would have already been exhausted. Optimal results from a Hadoop implementation depends on choosing the right hardware and software stacks. The table above shows system stack recommendations that can help the organization in the planning stages. Now, let's look at a few examples of industry setup clusters. PSG Tech, Coimbatore, India. This organization works on determining evolutionary linkages and predicting molecular structures. The dynamic nature of the algorithm, coupled with the data and compute parallelism of Hadoop data grids, improves the accuracy and speed of the sequence alignment. The cluster size varies from 5 to 10 nodes. The cluster nodes vary from 2,950 quad-core rack server with 2 times 6 MB cache and 4 times 500 GB SATA hard drive to E7200/E7400 processors with 4 GB RAM and 160 GB hard disk. Specific Media, United States. They use 2 Apache Hadoop clusters for log aggregation, reporting, and analysis, all nodes of 16 cores, 32 GB RAM. Cluster 1, 27 nodes, total 432 cores, 544 GB RAM, and 280 TB storage. Cluster 2, 111 nodes, total 1,776 cores, 3,552 GB RAM, and 1.1 petabyte storage. Yahoo, United States. Yahoo has more than 100,000 CPUs in over 40,000 servers that run Hadoop, with its biggest Hadoop cluster running 4,500 nodes. All told, Yahoo stores 455 petabytes of data in Hadoop. That's huge. It is approximately 4 times larger than Facebook's beefiest Hadoop cluster. Following is the quiz section. To check